Hi everyone. So today for Unit 4 we are going to be learning how to relate moles to concentration and volume. So in our mole angel, that is this triangle over here. We're also going to be taking a look at another equation that helps us with dilution. C1V1 equals C2V2, where C is concentration and V is volume in liters. Okay, so our goal for today is to be able to express concentration of a solution in various methods, and then at a later date we will learn how to do so experimentally. So recall from some of the definitions from your last booklet, Introduction to Solubility. Concentration is the ratio of solute to solvent per unit volume of solution. So let's say we were boiling some pasta, right? Our solute would be our salt, or NaCl. Our solvent would be our water. And our solution would be salt and water in our pot, okay? Now, the term concentrated means there is a high ratio of solute to solution. So this is when your pasta water is quite salty and your pasta turns out quite salty, okay? Now dilute is the opposite. It is a low ratio of solute to solution. So that's when you didn't add enough salt and your pasta kind of turns out quite bland because the water is not salted enough. Okay, it's a very low ratio of solute to solutions. So one way for us to be able to determine the concentration or molarity of a solution is to use the formula C equals N over V. So little c is concentration, and concentration is measured in moles per liter, or capital M, molarity, equals little n for moles over capital V for volume. And remember that volume has to be measured in liters, okay? So always convert to liters first, okay? Now some of you might be wondering, well, Miss K, why is there this capital M? Isn't that molar mass? Well, watch out, because concentration, mole per liter can be, we can use the unit capital M to mean mole per liter, right? But capital M we also use in our equation for molar mass. So it depends, is M a variable in a formula or is M a unit? Okay, sometimes you'll see both. So look out for that, okay? And sometimes simpler to write capital M as your unit for mole per liter than writing out mole per liter. Okay, that's all that this means. So remember, to work out number of moles, we will use mass and molar mass, or we will use our old equations from Unit 3 that you can find on the back of your periodic table, as well as this equation, C equals N over V, is also on the back of your periodic table. Okay, so that's one way we can look at concentration related to volume and moles. Now, sometimes we'll also have some dilutions. So what does it mean to dilute something? To dilute a solution means to add solvent without the addition of more solute. Of course, the resulting solution is thoroughly mixed so as to ensure that all parts of the solutions are identical. The fact that the solute amount stays constant allows us to develop the following equation. So, and a real life example of this is if you found your pasta water to be super salty, and let's say you tasted it and you're like, oh, this is way too salty. You wanted to dilute that solution, you would add more solvent, which is water in our example. Okay, so that is what we're doing. So we can use a formula to calculate our concentration when we dilute a solution. So C1V1 equals C2V2. So C1V1, that's the initial concentration in mole per liter, and initial volume per liter. So on the left-hand side, this is your initial values. And on the right-hand side, these are your final values, what you hope to achieve, okay, when you're diluting a solution. Remember to always have volume in liters, okay, and concentration is always in mole per liter. So let's do an example. What is the final concentration when 4.5 liters of 3.0 mole liter car battery acid is diluted to 20 liters? So let's write out what we're given. It's asked, what is the final concentration, so C2 is unknown, when 4.5 liters, that's your initial volume, of the initial concentration of 3.0 mole per liter, okay? Or you could write it as 3.0 M, right? Those units mean the same thing. Molarity, capital M. And we want to find out if we dilute it to 20 liters. So V2 is going to be 20.00 liters. So when we solve, we're going to use our equation C1V1 equals C2 capital V2, and we're going to rearrange it for C2 is equal to C1V1 over V2. Let's plug in our values where our concentration is 3.0 mole per liter times 4.5 liters over 20.00 liters. When we solve for it, we get 0.675 mole per liter. Now check your sig figs. You have two significant figures here, so you need two significant figures in your final answer. So your final answer should be 0.68 mole per liter. Okay, because the 5 rounds up. Now, please pause this video. Try example 2. All right, so for example number 2, if you need to prepare 4.5 liters, so this is your final values, you're looking for 4.5 liters, that's your V2, and your C2 is 1.0 mole per liter. What volume of concentrated acetic acid, so that's your C1, is required? So we're looking for V1. Okay, so if you did this calculation, you would get 0.26 liters. Okay, so if you want to check the full solution, click on our OneNote to see the full solution. Now let's take a look also at example 3. Okay, notice this, we're going to be really focusing on the particulate level and being able to visualize it. So if we were to dilute, so here's our initial beaker and here's our final beaker, and what we did was we added 1 liter of, let's say, water. Okay, and look at the difference in what we see happening in the beaker. Okay, remembering that these red circles represent your solute and the solution that it's in, or your solvent, is your water, for example. Okay, oops, I'm going to write this as your solvent because it's not always water. So I've given you the values. Pause this video, try this calculation with your C1V1 equals C2V2 equation. Okay? All right, so if you use the right C1V1, C2V2 values and rearrange it correctly, for this example, you would get 2.5 mole per liter. However, it's one significant figure, so it should be 3 mole per liter because 0.5 would round up. Okay, again, pause this video and look at the full solution in our OneNote if you would like. If you're finding dilution and concentration still challenging, please make sure to watch the 2 videos that are linked into this note, and you can complete the following practice on dilution and concentration. All right, and then I'm going to walk you through one more example where we're using our moles in order to figure out our concentration. Now you'll see as you're doing your practice, there's a tricky problem. That's a challenge for you to try. There's also an extension for those of you that want to learn a little bit more. It's not testable, but there are multiple ways you can express concentration, so feel free to look through that if you're interested. Again, not testable, but encouraged for you to look through, as you might see it in future years. And now we're going to do the first example together in the independent practice where we are asked to calculate the concentration in mole per liter of table salt, which is NaCl, in a solution of water if 45 grams is dissolved. So that's your mass, 45 grams in 1200 milliliters of water. Now right away, when you don't see volume in liters, you need to do your conversion. So remember that 1000 milliliters is equal to 1 liter. Okay, so this would be 1.200 liters. Okay, do your conversion first before you do any calculations. Always, always you want the right units before you go into your calculations, okay? So we need to figure out, well, which formulas are we going to use in order to get our concentration? Now we're given grams. We can't just go directly from mass all the way to concentration. Now looking at our mole angel, right? If we know our mass, okay, we can use this triangle to solve for moles. And then once we've solved for moles, we can then use this triangle to find our concentration. Okay, so let's try this out. So step number 1, we are going to use our mole equation for mass and molar mass, okay, of sodium chloride. So our moles of sodium chloride is what we want to find out first. So let's plug in what we know. We have 45 grams of sodium chloride. Our molar mass, when we calculate it, is going to be 58.44 grams per mole. When you plug that into your calculator, you get 0.76998 moles of NaCl. All right. Now that we have our moles, we can use our next equation, our new equation that we learned of C equals N over capital V. So let's plug in what we know. We just solved that our moles, we have 0.76998 moles, and our volume has to be in liters, is 1.200 liters, okay? Now if you're like, did I rearrange this equation correctly? Your units will also show you if you did so correctly, right? We want concentration in moles per liter, and that should be our final answer, and we will get the right units because we have mole per liter right here, okay? So when you plug it into your calculator, you get 0.64165 mole per liter, or some of you might write it as 0.64165 capital M, right? Both of those units are molarity, and that's okay to use either or, okay? And then if you think you're done, you have to make sure to double check your significant figures, okay? We have 2 significant figures as our least amount of significant figures in the question. So our final answer is 0.64 mole per liter, or 0.64 capital M, okay? So that's it for the lesson. Please complete the rest of the practice. You're going to see some stoichiometry using this new equation, and you'll also practice your dilution and your concentration calculations, okay? We'll see you next class. Thank you.